Hi folks, and welcome to my homework presentation for episode 113 of Paul McWhorter's series on how to get the most from your Raspberry Pi Pico W. In the last lesson, Paul was teaching us a little bit about how to plot live data using PyQt5. And for homework, he asked us to take some live data and not only plot it in PyQt5, but also send that data across the network to a server which would interpret the data and control an RGB LED. And specifically, the data he wanted us to generate, plot, and send is data that would be walking the HSV color wheel. I guess there's several ways to do that, and I'm going to show you three here real quick as part of this demo. The first two are derivative of the lesson that he gave us in 113, using sine wave data and using NumPy to plot sine wave data. And the third is, I think, using the more traditional HSV color wheel approach that we've used in prior lessons, so non-sinusoidal. More like a piecewise linear thing, and you'll see the difference between them. But first, let's do a demo, and let's get our server started up so that we can do that. All right. And as long as the onboard LED is blinking, the Pico is trying to connect to the network. As soon as it goes solid, it will be connected. That means we can now run our client. And we'll run the sine wave client first, and the sine waves are all offset by 120 degrees, and they're all static relative to one another. And this, I think, is probably the most faithful reproduction of the HSV color wheel relative to how we've done that in the past. It's not exactly the same because we're using sinusoids instead of the piecewise linear. But the idea here is to take the initial values, each time we plot the waveform, to take the initial values of the arrays, the red, the green, and the blue arrays, send that data across the network to the server, and then have the server plot it appropriately. And you can see that I'm sending red, green, and blue data as that data changes over the network right here. And through my wonderful fancy diffuser, you can probably see the colors changing, at least somewhat. It's difficult to do that with my particular camera that I have. All right, so that's one variant. I think this is closest to the sine wave solution for sending the HSV color wheel. However, Paul did also show us a version that had these three sine waves moving relative to one another, and we can do that by stopping the client, adding this count increment back in, and I need to save it this way so I don't accidentally stop my recording, and then rerunning the client. Now you can see the red, the green, and the blue all moving relative to one another, but it's the same idea. We're taking the initial values of the arrays that we're plotting, and we're sending that to the server to have that mapped to the RGB LED. All right? All right, so those are the sine wave solutions. And we'll talk about some of the code in a second. But next, I would just like to do the traditional HSV color wheel approach, the piecewise linear approach that we've taken before. So we'll run some slightly different code to get that going. And that probably looks familiar to those of you who have been taking this course from the beginning. It's sinusoidal-like, but it's not sinusoidal, right? It's that very piecewise linear treatment for each of the R, G, and B waveforms. But once again, we're taking the initial values of the array at any point in time when we update the plot, and sending those initial, the zeroth values of those arrays over to the client. Okay, so I think that's probably good enough for the demo. Can leave that plugged in. And we'll look at a little bit of software here. In the sine wave version, which is closest to what Paul taught us in the last lesson, all of the magic is happening here in the update plot routine, apart from up front just connecting to the network like we already know how to as a client. And then I have a couple of functions that I've written, one for sending a UDP command and the other for receiving UDP data. We use the send command here to send the data. So creating the new y-sine, y-sine2, and y-sine3 arrays for the three different sinusoidal plots, exactly as Paul did it, using the set data to print that new information out on each update plot. That's exactly like Paul did. The only thing I did here was to take the first value or the 0th value of each of these y value arrays, the sine arrays, and then offsetting it, because we know that we're creating sinusoids that vary between +1 and -1. We have to add 1 to get to get the range between, fully positive, right? We can't deal with the negative numbers very easily, so we've got to offset by 1, and that means now our magnitude is between 0 and 2, and we have to divide that 2 to get it back into the right space before we scale it. Right, so I do this offset and scaling for each of red, green, and blue, and then I add these to a particular command that I'm going to send over the network to the server. And it begins with RGB LED and a slash. The server is going to look for that. If it sees it, it's going to expect 3 pairs of data, one that says red with the string value of the red calculation, green plus the string value of the green, and the same for blue. And then it will use the UDP send command to send it. And in this case, count equals count plus 1, because we are speeding up 2 out of the 3 waveforms relative to the initial waveform, just in that particular example. In any case, that gets the data sent across the network to the client, where the client is going to look for the RGB LED. I should put this over here so I know you can see it. The client is going to look for RGB LED in the message that it's decoded. If it sees it, it's going to expect a command of this particular format. It's going to separate this data appropriately, and because this is, looks a lot like a key value pair for each of these, I put it into a dictionary and use and reference the dictionary to get the values out before I adjust the duty cycle on the PWMs for the red, green, and blue LEDs on the Pico. Right? And this code stays the same regardless of whether I'm using traditional HSV or one of the sine wave variants. Right? It doesn't matter, because they all send the command in the same format. Right? The HSV code was a little bit different. Obviously, we can't use NumPy to generate what this data set looks like. What we have to rely on is the function similar to what we've done in creating this piecewise linear HSV formula in the past, right? So I added that as a function here, and we're going to use that function when creating the arrays that we want to plot. And there are 4 arrays. One is just the X array. It's going to go between 0 and 359 because I want 360 points in the HSV graph, right? So 1 for each degree in the color wheel, very convenient. And then the R, G, and B arrays are going to have the R, G, and B values for each of these 360 points as determined by the HSV function, HSV to RGB function that we've written in the past. All right, we're going to create that once, right at the very beginning. And in the update plot, we're going to take those array values, but I'm going to shift the red, green, and blue, that is the Y values for red, green, and blue, to the left 1 value each time through the update plot. So I had to write a little function that will do that. You pass it one of the arrays, R, G, or B, and it's going to shift the data left 1, and then take the one that's shifted out on the left and tuck it back in the right. So it's a circular shift left. And that's all we have to do. We've got to shift it once, then replot it, scale the R, G, and B values that we get, and then create the command in the same format that we talked about before and send that command to the server. And really, that's it. In any case, always fun and challenging to work on what Paul gives us, and we'll see what he has in store for us this coming week. Thanks, everybody.